You've found Dreamtime Science, a peaceful corner where we unravel the mysteries of our universe one whisper at a time. Let the gentle current of discovery carry you towards sleep. You know, I've been thinking about something as simple as the color of the sky. It's easy to take for granted, but there's something remarkable about why it's blue during the day, and then turns those soft reds and pinks at sunset. It's like the sky is painting its own quiet story every day, and I'm excited to share the gentle science behind those beautiful colors with you. It's one of those little wonders that feels both peaceful and full of surprises. A soft tap of the like button or a whispered subscription tells me these calming discoveries resonate with you. What aspect of science brings you the most wonder? Let's prepare for tonight's journey. Find your most comfortable position, let tension float away from your body, and take 3 slow, peaceful breaths. The sun is on its slow ascent, a molten coin pressing gently against the morning horizon. Its light spills across the world, gilding rooftops, glazing the dew-stippled fields, and, most unmistakably, painting the infinite ceiling above us with a blue so deep and gentle that we have come to take it for granted. It is not merely the backdrop of our days, not just the silent canvas upon which clouds and birds and dreams drift. The blue of the sky is a companion, a comfort, and perhaps most curiously, a riddle that has haunted the human mind for millennia. In the soft hush before sleep, lying beneath a window or perhaps recalling some cherished afternoon, consider that blue, the dome that cradles our world. How strange if you pause to think that the sky is not the colourless void of space, nor the fiery gold of the sun's own heart. Why not violet, or crimson, or green? Why does our sky wear this particular shade, so familiar and yet so enigmatic? Before the age of science, the mystery of the sky's colour was a wellspring of stories. For our ancestors, the world was alive with spirits and gods, and the sky was no exception. In the mythologies of many peoples, the blue vault above was imagined as an ocean. The ancient Egyptians believed the sky was the goddess Nut, her arched body stretching from horizon to horizon, painted with the blue of lapis lazuli and speckled with stars. She swallowed the sun each night and birthed it again every morning, a divine cycle, her colour a symbol of rebirth and protection. Elsewhere, in the Norse sagas, the sky was the skull of the primordial giant Ymir, raised by the gods to form the heavens. Its blue, they said, was the pallor of his ancient bones, or sometimes the afterglow of distant fire. The Greeks, too, looked upward and wondered. To them, the vault above was the domain of Uranus, primordial god of the sky, whose name still echoes in the planetary realm. Homer, in his epic verse, described the sea as wine dark, but he was more reticent about the sky's hue, suggesting that the ancient Greeks, in their poetic language, were captivated more by the changing light than by the steadfast blue. Other cultures imagined a great plain of crystal or a tent of blue silk stretched across the heavens. In Hindu cosmology, the sky could be the realm of Indra, king of the gods, whose palace was built of sapphires and mirrored the blue depths above. In Chinese legend, the sky was a great dome supported by pillars, each painted in colours that shifted with the seasons, but blue, the colour of spring, was always a sign of renewal and peace. Across continents and centuries, the blue sky has been the subject of parables, of songs, of whispered prayers. To gaze upward was to enter a dialogue with the infinite, to touch the threshold between mortal earth and the divine. Yet, despite all the stories and symbols, the essential question remained unresolved. Why, truly, is the sky blue? In the quieter corners of the modern mind, the question still lingers, though perhaps with a different timbre. It is a question for the curious child, sprawled in the grass, squinting upward with a mind unclouded by answers. It is a question for the poet, the philosopher, the painter dabbing cerulean onto canvas. It is a question for scientists too, who seek not only to explain, but to understand, in the deepest sense, the interplay of light and air that makes our world so beautiful. Let us linger for a moment in this place between wonder and explanation, where the blue sky is both an everyday companion and an eternal mystery. It is a mystery that has found its way into the fabric of our stories, our songs, and, in the modern era, our popular imagination. Take, for instance, the world of fiction and film. The blue sky is shorthand for hope, for wide-open possibility, for the freedom of flight. In the beloved classic The Wizard of Oz, Dorothy sings of a place somewhere over the rainbow, way up high, and the dreams that you dream of once in a lullaby. The rainbow, an arc of spectral colours painted across that same blue sky, is a promise of something magical, a bridge between what is and what might be. The sky's own colour is the backdrop to dreams, to journeys, to the possibility of transformation. In The Little Prince, Antoine de Saint-Exupéry writes of his tiny hero journeying among the stars, his head filled with questions. The blue sky is both a barrier and an invitation, a thing to be crossed in pursuit of friendship and understanding. In Miyazaki's films, the sky is alive with fantastical airships and flying castles, its endless azure a stage for adventure and reverie. The blue sky in these stories is never just scenery. It is a character, an aspiration, a gentle force shaping the world below. Even in the world of science fiction, where alien skies flash with unfamiliar colours, the blue of Earth's own sky is a symbol of home. Astronauts, gazing back at the planet from orbit, have written movingly of the pale blue dot suspended in the black. The thin shell of atmosphere that colours our days is, from a cosmic perspective, vanishingly slight, yet it is all that stands between us and the void. The blue sky is woven into our languages too. We speak of blue sky thinking, of ideas unbounded by convention. We describe our moods as blue, our hopes as sky high. In Japanese, the word ioi encompasses both blue and green, a reminder that colours, like stories, are shaped by perception as much as by physics. In English, azure conjures the clearest noon, cerulean, the richness of a summer afternoon, indigo, the deepening dusk. Each word is an attempt to capture in sound and sense the elusive qualities of the sky's own palette. Yet for all its familiarity in song and speech, the blue sky holds subtle surprises. Its hue is not constant, but changes with the hour and the season. At sunrise and sunset, the dome is painted with gold and crimson, the blue retreating as longer, redder rays spill across the horizon. In the height of noon, the blue is at its most saturated, a nearly tangible colour that seems to press down with gentle weight. And on some days, after rain, the sky is so clear and so blue that it seems almost unreal, as though a window has opened onto another, purer world. But the sky is not always blue, and this too has prompted wonder. There are the days when it is pewter and leaden, a mass of rolling cloud. There is the rare green of storm light, the eerie yellow before a tornado, the deep black of a moonless night. And always there is the question, what gives the sky its colour, and what takes it away? The earliest attempts to answer this question were as varied as the myths that preceded them. The philosopher Anaxagoras, living in ancient Greece, speculated that the sky's blue was the result of light reflecting off the sea and mingling with the air. Others imagined the sky as a solid sphere, painted blue like a bowl inverted over the earth. Aristotle, with his usual mixture of insight and error, suggested that the blue was due to the interaction of sunlight with water vapour, the same process, he thought, that made the sea look blue. These explanations, though incomplete, were not wholly devoid of truth. The ancient thinkers were limited by the tools and concepts of their time, but they sensed that the colour of the sky was bound up with light, with air, with water, with the dance of elements. In this, They were close to the heart of the matter, even if they could not yet see its workings in full. As centuries passed and understanding deepened, the question of the sky's colour became a touchstone for scientific inquiry. It was not, as Isaac Newton discovered, the product of a single substance or a painted dome, but of something more subtle, the behaviour of light itself as it journeyed through the ocean of air surrounding our world. But before that revelation, there were centuries of speculation and observation, of careful watching, of tentative guesses, of theories spun from the cloth of curiosity. The blue sky was a puzzle at once obvious and elusive, a daily miracle hiding in plain sight. Even as science began to peel back the layers of mystery, the sky's colour remained a source of inspiration. Artists sought to capture its shifting tones in paint and pigment. Poets wrote of the blue above the trees, of heaven's sapphire arch, of the infinite tender sky. The Impressionists, in particular, were fascinated by the interplay of light and atmosphere, by the way the sky's colour changed with the weather, the hour, the season. Claude Monet painted the same haystack or water lily pond again and again, each time under a slightly different sky, his brush seeking not just accuracy, but the feeling of light itself. The blue sky is, in the end, both a physical phenomenon and a canvas for the imagination. It is shaped by the laws of nature, but also by the stories we tell, the words we use, the questions we ask as we look upward. It is as much a creation of the mind as of the world, and its meaning shifts with each culture, each era, each wandering thought. In the modern age, the question, "Why is the sky blue?" has become a kind of shorthand for scientific curiosity. It is the sort of question that children ask and adults often struggle to answer, trapped between the simplicity of wonder and the complexity of truth. It is a question that invites us to look more closely, to see the world not just as it is, but as it might be, if only we understood its secret workings. Let us then hold on to that sense of wonder as we begin to unravel the mystery. The sky's blue is not a trick of the eye, nor a mere reflection of the sea, nor the paint of gods or giants. It is a phenomenon born of light and air, of photons and molecules, of the interplay between the sun's radiance and the tenuous veil of atmosphere that wraps our world. But before we descend into the realm of wavelengths and scattering, let us pause and linger a little longer in the gentle embrace of myth and memory. For the blue sky is more than just a scientific puzzle. It is the colour of yearning and possibility, the mark of a world both known and unknowable. It is the silent witness to our days, the stage for our stories, the gentle guardian of our nights. As you close your eyes and drift towards sleep, imagine the vast azure canvas above you, not as an answer, but as an invitation to wonder, to question, to dream. For in the end, the question of why the sky is blue is not just a matter of physics or poetry, but a doorway to the deeper mysteries that lie all around us, waiting to be seen. And so, with the sky's gentle blue still echoing in your mind, we begin our journey. The next step will take us deeper into the realm of sunlight itself, where colours are born and scattered, and where the secret of the sky's hue begins to unfold. The world is woven from invisible threads, and among the most elusive of these is light itself. It is easy, perhaps too easy, to imagine light as a stream of tiny golden marbles, pinging their way through space in straight, unwavering lines. Or to treat it as a gentle ripple undulating through some ethereal ocean, bending and folding as it meets the contours of the world. Yet light is neither quite a particle nor quite a wave, and its journey through the fabric of reality is far from straightforward. As we turn our gaze to the dance of light, the scattering, the splitting, the intricate choreography invisible to our naked eyes, we find ourselves tiptoeing on the edges of comprehension, reaching for metaphors that strain and sometimes snap beneath the weight of the truth. Let us drift now, quietly, into the heart of this invisible ballet. Picture, if you wish, a single shaft of sunlight filtering through an open window at dusk. It appears solid, almost tangible, as it catches motes of dust and highlights the swirling currents of air. But this shaft is not a continuous beam, not a rod of substance. Instead, it is the sum of countless photons, each a discrete packet of energy, each born in the furnace of the sun, each flung across the yawning gulf of space, and each now entering an utterly new phase of existence as it meets the atmosphere of our blue planet. It is here, in this liminal region where cosmos meets air, that the story of scattering truly begins. The air, to our eyes, is clear and empty, a space to be filled by the more tangible elements of the world. Yet on the scale of light, the atmosphere teems with obstacles, molecules of nitrogen and oxygen, of argon and trace gases, each smaller than the wavelength of visible light. When sunlight collides with these minuscule wayfarers, something wondrous occurs. The light does not simply bounce like a ball striking a wall. Instead, the oscillating electric field of the photon induces a trembling in the molecule. Electrons shudder and sway, pushed and pulled by the passing wave. This trembling in turn sets off its own ripples, re-radiating energy in all directions, a process we call Rayleigh scattering, after the English physicist who first unravelled its mathematics. The implications of this process are profound. Shorter wavelengths, those that correspond to blue and violet, are scattered more strongly than longer, redder wavelengths. This is why, as we gaze up from the surface of the earth, the sky appears to us as an endless vault of blue. The azure dome is not a solid thing at all, but the cumulative effect of sunlight's blue hues being scattered in all directions. It is a color that arises not from a pigment, but from the sum of countless random scatterings, each one reshaping the path of a single photon on its journey from sun to eye. Yet there is a puzzle here, a whisper of something more. If violet is scattered even more powerfully than blue, why is our sky not a deep royal purple? The answer lies, as so often, in the subtleties. The sun emits less violet light to begin with, and our eyes are less sensitive to those short wavelengths. The blue wins out, a compromise between the physics of scattering and the biology of perception. But let us not stop at the sky, for the dance of light is everywhere, weaving its influence through every corner of our world. Consider the familiar sight of a red sunset. As the sun descends toward the horizon, its light must traverse a thicker slice of atmosphere. The path grows longer, the opportunities for scattering multiply, and the blue and green components of sunlight are scattered away, leaving behind the more stubborn reds and oranges to reach our eyes. The sunset, then, is a natural filter, the atmosphere selecting and discarding colors with each passing moment, until the sun itself is a smouldering ember at the edge of the world. Yet even this account, elegant though it may seem, is but a surface, for the world is rarely so clean, so free of complication. The atmosphere is not a perfect uniform soup of molecules. It is laced with dust, with droplets of water, with a bewildering array of particles both natural and artificial. Each of these introduces new forms of scattering, Mie scattering, for example, named for German physicist Gustav Mie, who extended our understanding to larger particles. Unlike Rayleigh scattering, which is most efficient for tiny molecules and preferentially scatters shorter wavelengths, Mie scattering is less selective, affecting all wavelengths more equally. This is why clouds, composed of droplets much larger than the wavelengths of visible light, appear white or grey rather than blue. Their droplets scatter sunlight in all directions, blending the colours into a featureless wash. Now, let us dwell for a moment on the nature of these droplets. Each one is a world in miniature, a lens with its own unique properties. When sunlight encounters a raindrop, the light is refracted, bent as it enters, reflected off the inner surface, and refracted again as it exits. In this journey, something exquisite occurs. The white sunlight is split, fanned out into its constituent colors, the same effect that a prism achieves on a laboratory bench. If the geometries are just so, the light emerges from the drop at a particular angle, and the sky is adorned with a rainbow, a fleeting arch of spectral splendor. Yet even as we marvel at the rainbow, we must acknowledge its ephemeral, subjective nature. No two observers see the same rainbow. Each one is a personal vision, a consequence of one's unique vantage point and the countless droplets serving as a canvas. The rainbow exists not as an object in the sky, but as a phenomenon of light and perception, a reminder that the ballet of photons is always, in the end, entwined with the act of seeing. But the invisible ballet grows stranger still as we press deeper. We have spoken of scattering and refraction as if the photon's path were a singular, well-defined trajectory. Yet the true nature of light, as revealed by quantum mechanics, is more ambiguous, more mysterious by far. In the quantum world, the photon can be thought of as exploring every possible path between its point of origin and its destination, each path contributing its own probability amplitude to the final result. The straight line, the zigzag, the looping detour, each is part of the sum, and the interference of these amplitudes gives rise to the patterns we observe, the fringes of an interference experiment, the subtleties of polarization, the very texture of the rainbow's edge. Richard Feynman, the physicist and poet of quantum electrodynamics, once invited us to consider this notion, that at every point in its journey, a photon does not choose a path, but samples all paths in a manner beyond our ordinary understanding. The mathematics is formidable, but the conceptual leap is profound. The apparent simplicity of a ray of sunlight belies an infinity of invisible possibilities, each one woven into the tapestry of the world we perceive. There are further mysteries, too, in the polarization of light. When sunlight scatters in the atmosphere, the electric fields of the photons become aligned in particular directions. This polarization can be detected by sensitive instruments or even by the compound eyes of insects. Some creatures, such as bees and certain birds, are attuned to the polarization patterns in the sky, using them as a celestial compass to navigate across vast distances. Once again, the invisible ballet is not only a matter of physics, but of biology, of the ways in which life has evolved to read and interpret the hidden signals in the light that bathes the world. The complexity deepens as we consider the limits of our understanding. For all our equations and experiments, there remain questions that defy easy answers. Why, for instance, does light travel at the speed it does, neither faster nor slower? Why does it interact with matter in just these ways, and not others? Even the phenomenon of scattering, so neatly described by mathematical models, reveals its limitations in the real world. The atmosphere is not static. It shifts and flows, shaped by winds and weather, by pollution and the ever-changing balance of gases. The scattering of light is thus a dynamic, evolving process, sensitive to the smallest perturbations, the tiniest changes in the composition of the air. And then there are the edges of comprehension, where our models begin to break down. When light encounters particles smaller still, subatomic particles, quantum fluctuations, the rules become hazy, the certainties dissolve. In the high-energy realm of the ultraviolet, or in the rarefied heights of the upper atmosphere, new forms of scattering emerge. Raman scattering, Compton scattering, each with its own peculiarities, each demanding fresh insight. The ballet of light is, in truth, a symphony too intricate to be captured in its entirety by any one theory or metaphor. We glimpse only fragments, illuminated by the narrow beams of our understanding. Yet it is perhaps these very limits that make the study of light so compelling. The more we learn, the more we find ourselves drawn toward the edge of mystery, where simplicity gives way to complexity and certainty to wonder. the scattering of a photon by a molecule, the bending of a sunbeam by a droplet, the rainbow unfurling in the sky. Each is both an answer and a question, a momentary glimpse into the unfathomable depths of nature. So, as night gathers and the last rays of sunlight fade from the sky, consider the invisible ballet that unfolds above and around us. The air, seemingly empty, is a stage upon which photons dance and scatter, split and recombine, their trajectories shaped by chance and necessity, by the laws of nature and the accidents of history. The colours we see, the patterns we marvel at, are but the outward signs of this deeper choreography, a dance that began long before we opened our eyes and will continue long after we close them. The ballet is ongoing, relentless, and endlessly subtle. Even now, in the gentlest glow of twilight, photons stream from distant stars, scatter in the thin air above, and carry with them the secrets of the cosmos. They illuminate our world, reveal its textures and colours, and hint at mysteries yet to be unravelled. And as we drift further into the night, the invisible ballet continues, silent and unseen, waiting for the next observer to take up the thread and follow the dance into realms unknown. There is a peculiar satisfaction in seeking answers to the oldest riddles, and few are older than the question of the sky's shifting hues. For most of human history, people gazed upward and wondered, content to weave stories or record the moods of the heavens with pigments ground from earth and plant, inked onto parchment or painted onto cave walls. But as centuries passed and curiosity deepened, so too did the desire to move beyond mere observation, to probe, to measure, to test, to understand not just what the sky looked like, but why it looked so. This quest, stretching from ancient philosophers to the engineers of today, has been marked by ingenuity and the relentless refinement of our tools. The earliest instruments for studying the sky's colours were, of course, the eyes and minds of those who watched it. Yet even here, subtlety was at work. The human eye is a remarkable device, evolved over eons to detect the faintest shift in daylight, the delicate transition of dusk. In many ways, our biology is the first and most personal scientific instrument, and for centuries all we could do was compare what we saw to what others recorded. The poetic language of early observers, Aristotle's musings on the blue of midday, the pinks and golds at sunset, hinted at the complexity of the phenomenon, but lacked the precision needed to unravel its secrets. Still, even in antiquity, there were attempts to capture and codify the sky's palette. Some of these were practical. Egyptian artisans, for example, developed pigments that mimicked the colours of the heavens, blending minerals to create the deep blue of lapis lazuli or the vibrant azure of copper salts. Others were more philosophical, as when the Greek philosophers speculated about the composition of the air and the nature of light. They wondered if the sky's colour was a property of the air itself, or the result of sunlight passing through it. But it was not until the Renaissance, with the rise of experimental science, that people began to design instruments capable of dissecting the sky's light. The first key innovation was the prism, a simple wedge of glass or crystal, which Isaac Newton wielded with unmatched curiosity in the 17th century. In a darkened room, Newton directed a shaft of sunlight through a tiny hole, then passed it through a prism, watching as it fanned out into a rainbow on the far wall. Here, in the spectrum splayed across stone, was proof that white sunlight was not pure, but made of many colours blended together. Newton's experiments were, in their way, a revolution. They provided the first concrete evidence that light could be split and analysed, that colours were not inherent in objects or the sky, but emerged from the interplay of light and matter. With a second prism, Newton recombined the colours back into white, demonstrating that the division and blending of light was a physical process, not a trick of the eye. And though Newton himself did not fully grasp the mechanisms behind blue skies or red sunsets, he gave later scientists the tools to pursue those mysteries further. For much of the next 2 centuries, the prism remained the central instrument for studying the colors of the sky. Scientists and natural philosophers carried them into the field, observing how sunlight filtered through clouds or scattered in the morning haze. They began to notice patterns. The blue of the sky was not uniform, but shifted with the sun's angle, the clarity of the air, the presence of dust or smoke. Some kept detailed journals, comparing the sky's appearance in different seasons or after storms. It was in the 19th century, however, that the investigation of sky colors became truly systematic. By then, the field of optics had advanced, and researchers began to design more sophisticated instruments, spectroscopes, which could split light into its component wavelengths and measure their intensity. Unlike the simple prism, which scattered colors broadly, the spectroscope allowed for precise analysis. With a narrow slit to admit light, a collimator to align it, and a finely calibrated prism or diffraction grating to separate the wavelengths, the spectroscope turned the sky into a measurable tapestry. One of the earliest and most persistent skyward experimenters was John Tyndall, an Irish physicist with a knack for both demonstration and explanation. Tyndall was fascinated by the blueness of the sky and sought to reproduce it in the laboratory. He set up glass tubes filled with liquids or fine particles, directing beams of sunlight through them and observing the scattered light. In one famous experiment, Tyndall filled a long tube with clear air and shone a bright light through it, watching as particles suspended in the air scattered shorter wavelengths, the blue more strongly than the reds and yellows. The effect was a pale, sky-like glow, and Tyndall's work helped to confirm what would become known as Rayleigh scattering. Lord Rayleigh, or John William Strutt, was the scientist who, in the late 19th century, gave this phenomenon its mathematical form. Using meticulous measurements and careful reasoning, Rayleigh showed that the scattering of light by tiny particles, smaller than the wavelengths of visible light, was far more efficient for blue than for red. He derived equations that could predict the intensity and color of scattered light under different conditions, and with them the sky's palette began to yield its secrets. Yet the quest was not only about theory and mathematics. It was also a matter of ingenious devices, crafted to bring the sky's light down to Earth where it could be measured. Early spectrometers were beautiful instruments, made of brass and glass, with rotating arms and precision lenses. Scientists would mount them on tripods, point them upward, and record the faint traces of color at the edge of the visible spectrum. As the 20th century dawned, new tools emerged. Photography became an ally of the skywatcher, allowing the capture of subtle gradients and fleeting phenomena. Early glass plates, coated with silver halides, were sensitive to blue and ultraviolet light, making them ideal for recording the pale shades of the daytime sky or the fiery reds of sunset. With the invention of color film, the study of sky colors grew more precise still, as researchers could compare images taken at different times and places, assembling a visual archive of the atmosphere's moods. But not all experiments were grand or elaborate. Some of the most revealing were delightfully simple. Consider the work done by Charles Fabry and Alfred Perot in the early 20th century. They devised an experiment using little more than glass plates and sunlight. By stacking 2 flat glass plates with a small gap between them, they created what is called an etalon, a device that produces interference patterns when light of different wavelengths passes through. By analyzing the resulting fringes, they could deduce the composition and thickness of the atmosphere above, and in doing so, gain insight into why the sky's colors changed with altitude and weather. Other experiments ventured higher still. With the advent of balloons and later aircraft, scientists could carry their instruments above the haze and dust of the lower atmosphere, peering at the sky from new vantage points. In the 1930s, Auguste Piccard, ascended to the stratosphere in a pressurized gondola carrying a battery of cameras and detectors. From these heights, the sky's blue faded to indigo, then to the blackness of space, a visual confirmation that the sky's color is a product of our particular atmospheric cocoon. Throughout the 20th century, the tools of the Skyward quest grew ever more sophisticated. Photometers were developed to measure the intensity of light at different wavelengths, their sensors calibrated with exquisite care. Some were carried aloft by weather balloons or fixed atop observatories in remote locations far from the glow of city lights. Others were mounted on satellites, peering down at the Earth's limb, the curved edge of the atmosphere, where sunrise or sunset could be observed in its purest form. The advent of electronic detectors, such as photomultiplier tubes and charge-coupled devices, CCDs, revolutionized sky color research. These sensors could count individual photons, capturing even the faintest shades of twilight. Astronomers and atmospheric scientists used them to build detailed spectra, mapping the subtle absorption bands of ozone and other atmospheric gases, the fingerprints of particles and pollutants, the shifting gradients of color from horizon to zenith. But for all the precision of these modern tools, a spirit of playful curiosity persisted. Amateur skywatchers devised homemade spectroscopes from CDs or diffraction gratings, pointing them at the sky and capturing rainbows with their smartphones. School children scattered milk in water to mimic Rayleigh scattering, watching as a bright beam of light turned the liquid pale blue. Even in an age of satellites and supercomputers, the quest to understand the sky's colors remained accessible to anyone with a keen eye and a willingness to experiment. The story of these tools is, in many ways, a story of collaboration between disciplines, between generations, between nations. The study of the sky's colors draws together physicists and chemists, engineers and artists, meteorologists and astronomers. It demands the precision of laboratory measurement and the patience of long-term observation, the creativity to design new instruments, and the humility to trust what the data reveal. One cannot help but be struck by the sheer variety of clever experiments conducted over the centuries. There were those who measured the polarization of skylight, discovering that the sky's blue is not just a uniform wash, but subtly organized, its light vibrating in preferred directions. There were those who charted the colors of the sky at the poles, where the sun barely rises, and at the equator, where it passes overhead in a blaze. Some tracked the changing sky after volcanic eruptions, noting how the injection of dust and ash could turn sunsets a lurid crimson or deepen the midday blue. There were even experiments that reached beyond our planet. Instruments aboard spacecraft have measured the sky's color on Mars, where the thin atmosphere and fine dust produce a salmon-pink hue, or on Titan, Saturn's largest moon, where the sky is veiled in thick orange haze. These explorations remind us that our blue sky is not a universal fact, but a product of the unique mixture of gases, particles, and sunlight that envelops our world. And so, the quest continues, each new tool refining our vision, each clever experiment peeling back another layer of mystery. The colors of the sky, once the province of poets and dreamers, have become a subject of rigorous study, yet they have not lost their power to enchant. Even as we quantify wavelengths and model scattering, there remains something ineffable about the way the sky's colors shift and fade, something that no instrument can quite capture. Yet the future beckons with new possibilities. As we refine our tools and expand our reach, we find ourselves poised on the threshold of deeper understanding. The sky, once distant and untouchable, is now within our grasp, not just to observe, but to measure, to model, to predict. And yet, even as we master its physics, it continues to surprise us, to reveal new patterns and phenomena, to draw us ever upward in our skyward quest. In the hush of evening, as the last light fades and the blue deepens to indigo, one might reflect on the centuries of observation, the generations of experimenters, the evolution of tools from eye to prism, from spectroscope to satellite. Each has added its own brushstroke to the portrait of the sky. Each has brought us closer to understanding why the heavens are painted as they are. And still, there are mysteries yet to be unravelled, subtleties of light and colour that await the next clever experiment, the next inspired tool, the next curious observer willing to look up and ask, why? It is in this spirit of wonder, of ingenuity, of restless curiosity that the skyward quest continues, with new instruments ready to capture the next dawn, and new questions shimmering just beyond the horizon. The blue above, so familiar and so strange, still holds secrets in its shifting light. And as we trace its colours ever more precisely, we find ourselves drawn onward toward the liminal hour when sky and stars converge, and the study of colour becomes the study of night itself. As the sun sinks toward the horizon, its journey across the sky nears a daily conclusion, yet the display it gifts us is anything but an ending. The act of sunset, so familiar and yet so endlessly varied, is not merely a quirk of planetary geometry or a trick of atmospheric optics. It is an ever-renewed poem, painted by the universe and written in the language of light, scattering and shadow. To ponder why sunsets are red is to peer into the confluence of physics and perception, the intersection of cosmic chance and human meaning. When the sun stands high overhead, its rays take the shortest route through the atmosphere, carving a near-vertical path through the thin blue shell that cocoons our world. At these moments, blue light, with its short wavelengths, is scattered in all directions, filling the dome above with its cerulean glow. But as the sun lowers itself, the rays must traverse a far greater thickness of air. Their journey becomes oblique, drawn out through miles of turbulent gases, dust and vapour. More and more blue and green are scattered away, cast aside into the periphery of the sky, until only the longest, most persistent wavelengths remain. Thus, as the sun approaches the edge of the world, we find ourselves bathed in the warm embrace of reds, oranges and golds, colours that survive the gauntlet, colours that cling to the sun's departing face. Yet one must wonder, is there something more to this than mere physics? What is it about the red of sunset that tugs so insistently at the heart, that draws poets and painters, lovers and wanderers, into its fading glow? Why do we pause our lives, even if only for a moment, to watch the sky burn itself out in colour, as though the universe were whispering a secret only we can understand? The answer begins with the nature of colour itself. Long before the science of optics, before Newton split sunlight with a prism, colour existed first as experience. To early humans, the sky was a canvas on which the gods spoke, a place where the weather and the seasons, the omens and the unknown, wrote their stories. The colours of sunset became signals and metaphors, warnings of storms, promises of calm, symbols of endings and beginnings. Even after science revealed the molecular and atomic reasons for the sky's shifting palette, the emotional resonance of those colours persisted, perhaps deepened by the very knowledge that such beauty arises from the dance of light and air. Red, in particular, carries a weight of meaning. Across cultures and epochs, it is the colour of fire and blood, of passion and danger, of both the wound and the flame that cauterizes it. At sunset, red is not brash or violent, but softened, suffused with the golds and purples that edge it into dusk. It is as if the day's heat and energy, its urgent brightness, are being distilled into something more reflective, more contemplative. The sky does not rage as the sun departs. It blushes as if reluctant to let go. From a scientific standpoint, the redness of sunset is the triumph of endurance. Blue light, so easily scattered and dispersed, cannot survive the long passage through the atmosphere at dusk. Only the reds and oranges, with their longer wavelengths, persist. In this way, sunset becomes a metaphor for persistence, for the beauty that emerges not in the easy moments, but in those stretched thin by time and distance. The red of the sunset is the color that remains when everything else has been spent. Yet the story does not end with the sun itself. The atmosphere, that thin veil of air that cradles our lives, is not a perfect lens. It is filled with particles, dust, ash, pollen, the microscopic detritus of life and decay. These are the seeds of clouds and the silent witnesses to volcanoes, storms, and human industry. On some evenings, when the air is thick with particles, when fires have burned or winds have carried sands across continents, the sunsets turn more vivid still. The sky becomes a riot of scarlet and crimson, as if the world's own history is being written in light. Here, too, lies a connection to humanity. Every sunset is unique because every day's atmosphere is different. The colors we see are the sum of countless events, weather patterns, geological eruptions, the cycles of plants, and the actions of people. To watch a sunset is to witness a fleeting record of the world's invisible movements, to see, in color, the story of a day written across the sky. But perhaps the most profound connection is not in the colors themselves, but in the act of watching. For all our scientific understanding, for all our ability to chart and predict, there remains an irreducible mystery in the sunset. No two are ever quite the same, and no photograph, however skillful, can truly capture the sensation of standing beneath a painted sky as day fades into night. The light that reaches our eyes at sunset has traveled a path shaped by the entire world, by mountains and oceans, by forests and cities, by the breathing of plants and the exhalations of engines. We are, in that moment, witnesses to the sum of all these things, participants in a daily ritual that connects us not only to nature, but to each other. Consider for a moment the universality of this experience. Across the surface of the earth, as time zones slip past one another, billions of people have watched the sun set. Some have done so in silence, others in company, still others in the midst of festivals or moments of quiet reflection. The shared act of watching a sunset becomes, in a way, a thread that binds humanity across cultures and generations. The colors may differ, richer in the tropics, paler at northern latitudes, tinged with smog in cities, pure and cold in the desert, but the impulse is the same, to pause, to bear witness, to feel oneself a part of something larger and older than any individual life. The poetry of sunsets is written not only in light, but in memory. How many moments have been marked by the color of the evening sky? How many decisions, confessions, partings, and reunions have taken place beneath the gathering dusk? The red of sunset becomes a kind of shorthand for transition, a symbol of what is fleeting, but also of what endures. The day ends, but the world continues. The sun dips below the horizon, but its light lingers, scattered and refracted, until the last traces fade into night. In this there is a lesson that science can illuminate but not exhaust. The very fact that sunsets are red is a consequence of the universe's laws, of the way atoms and molecules interact with light, of the geometry of a spinning planet wrapped in air. But the meaning we find in those colors, the feeling that stirs when the sky ignites, is something that belongs to us. It is an invitation to step outside the boundaries of the self, to contemplate both the universality and the uniqueness of our lives. Each sunset is a reminder that we live in a world shaped by both necessity and chance, by the relentless logic of physics and the unpredictable accidents of weather and circumstance. There is, too, a kind of humility in the sunset's display. We are, after all, latecomers to this spectacle. For billions of years, sunsets blazed across the Earth's skies before any eye was there to see them. The colors that now enthrall us are the product of processes that long predate our consciousness, our stories, our civilizations. And yet, by the simple act of noticing, we become part of the story. The universe does not need an audience, but it has found one in us. Poets and philosophers have long sensed this connection. In the red of sunset, they have seen not only the end of day, but the promise of renewal, the assurance that, as surely as the sun departs, it will return. There is comfort in this rhythm, in the certainty that endings are followed by beginnings, that the darkness that falls is not final, but cyclical. The very science that explains the colors of sunset also reveals their inevitability. As long as Earth turns, as long as sunlight pours through our atmosphere, there will be sunsets. But science, for all its rigor, does not diminish the wonder. If anything, it enhances it. To know that the redness of sunset is the signature of molecules vibrating in air, of photons scattered and absorbed across miles of sky, is to see the world not as less mysterious but as more so. The knowledge that every sunset is the product of billions of tiny events, of atoms colliding, of light changing course, of particles drifting on the wind, only deepens the sense of awe. It is as though the universe, in all its vastness and indifference, has conspired to create moments of transcendent beauty, and then, without intent or malice, offered them to us. As the colors shift and deepen, as the last light slips away, there is a final note of mystery. The red that clings to the horizon is not only the end of day, but the beginning of something unseen. The night will come, filled with its own wonders. The stars will emerge, the planets will wheel across the sky, and the world will turn once more toward the dawn. But the memory of the sunset lingers, a quiet assurance that beauty is not the exception, but the rule, that the universe is, in its own way, inexhaustibly generous. And so, as the sun disappears and the sky surrenders to night, the redness of sunset remains as both a scientific fact and a philosophical invitation. It is the universe's poetry to humanity, written in light that has travelled millions of miles, scattered and transformed by the air we breathe, received by eyes and minds capable of wonder. It is a daily reminder that, for all our understanding, there is always more to see, always more to feel, always more to ponder. In the red of sunset, we find not only the explanation of physics, but the possibility of meaning, the sense that in witnessing the world we become a part of its endless, unfolding story. As twilight deepens and the world grows quiet, one can almost sense the next chapter stirring on the far side of the planet, where the sun will rise again and the cycle begin anew. The poetry of the sunset is thus unending, a refrain that echoes from day to day, from generation to generation, from the earliest dawn to the farthest future. In the redness of the evening sky, the universe speaks, and humanity listens, each of us adding our own quiet verse to the ongoing song of light and life. As our journey through the colors of the sky gently drifts to a close, like a comet tail fading into the hush of space, we find calm wonder in the soft blue daylight and the fiery reds of sunset. May your dreams carry these hues quietly with you, and when the stars twinkle anew, return to drift once more through the mysteries of the cosmos with me.